Okay, now let's calculate a one-way ANOVA. And we're going to do one of the simplest versions, an ANOVA that only has 3 levels. Okay? And this is how I suggest you do it. I suggest you write down what's called the source table first. Okay? You're going to have this in your head because it's not going to be on the formula sheet. But you got to know this relationship. We got 2 sources of variance between groups and within groups. We're going to have a sum of squares, a degrees of freedom, a mean squares, and ultimately an F ratio from all this. Okay? As I mentioned in the notes, I think these are the 2 toughest formulas to do, sum of squares between groups and sum of squares within groups. The rest of these are easy. If you can get these 2 down, you're good. Okay, so let's look at the data we're going to be given. The example in the lesson is going to look something like this, comparing these antidepressant medications. We have control group data, we have Paxil, and we have Prozac data. And we're trying to reduce depression symptoms here. We're seeing if one of these is better, if either is better than control. Okay? So I would start by giving you these 3 columns of data in black, and I would say, what's the one-way ANOVA? Okay? Well, if you go to the first formula right here, sum of squares between groups, here it is right here. It's a big clunky formula, but it's all the stuff you've done before. You've done in standard deviation, you've done in correlation, so there's really nothing new here. If you look at the formula, it just says sum of x1 and then squared. Well, here's the sum of x. You know how to do that. The sum of x1 is 57. The sum of x2 is 33. The sum of x3 is 34. So we just put those numbers in there, 57, 33, 34. Okay, we're going to square them in a minute here. And then it says it's over the sample size. Well, the sample size in this problem is the number of conditions, and there's 8 in each group. So it's just the sum of the x's over the sample size. And then in this part of the equation, we just do it again. We add the 3 sum of x's, and then we square them later. So there they are added together, and it wants the total n. So 8 times 3 is 24. That's what goes there. All right? And then we just solve the math. 57 squared is that. 33 squared, 34 squared. You add all the numbers, they get there. Then here they are divided by 8. Here's that 124 squared right there. And then ultimately we want to divide this by 24. And we come up with a sum of squares between groups of 46.083. Now we have one piece to our puzzle. 46.083. All right? There we go. Next step, we're going to solve for sum of squares within groups. And now we need to calculate sum of squares for within groups. All right? So we calculate sum of square between groups, and we have our between group formula, part of the puzzle. Next thing is to calculate this one right here. This is within groups. And this formula says sum of x1 squared plus sum of x2 squared and sum of x3 squared. So in order to get this, we have to make an x squared column. Very similar like we did in standard deviation and correlation calculation. We just take the x's and we square them. 8 times 8, 9 times 9, 5 times 5. So we end up with a sum of x1 squared column, a sum of x2 squared column, and a sum of x3 squared column. And these are the numbers we plug right in here. Okay? And then we do this second half of the equation. If you look carefully, this part of the equation is the same as the first part of the sum of squares between formula. So if you're smart, you just borrow that final answer that you got from sum of squares between 686.75 and plug it in right there. We did it all out again, like we did just a few minutes ago. We plug in the sum of x's, we do the calculations, and we get 686.75. When we do this calculation, our sum of squares within groups becomes 97.25. So we can plug that right in there. Okay? Great, we did the hardest part of this equation. Now we've got to add the degrees of freedom. The degrees of freedom for between groups is k minus 1. And k is the number of levels. Since we only have 3 levels here, k minus 1 is 2. We put a 2 right in there. Degrees of freedom for within groups is n1 minus 1 plus n2 minus 1 plus n3 minus 1. If you have more levels, you just keep going with this formula. We only have 3 levels, and we have 8 groups, 8 subjects in each level. So 8 minus 1 plus 8 minus 1 plus 8 minus 1, or 7 times 3 is 21. So our degrees of freedom for within groups is 21. All right, now we just got to calculate mean squares. And mean squares is this number divided by this number, and this number divided by this number. That's all it is. Mean squares for between groups is sum of squares between groups divided by degrees of freedom for between groups. And when we do that, 46.083 divided by 2 comes out to 23.042. And this, 97.25 divided by 21, comes out to 4.631. We have our mean squares. And the F ratio is just this divided by this. It's just mean squares between divided by mean squares within. So when you do that, you take 23.042 divided by 4.631, you come out with an F value of 4.976. That is our F value. We go to the F table to determine its significance using both the degrees of freedom of 2 and 21. That's how we solve a one-way ANOVA with 3 levels.